Hello, here's another AQA A-level Physics multi-choice question on progressive and stationary waves. If you'd rather choose a different question from the same topic, just click on the information card here, and if you can do the question yourself, pause the video now. If you got the answer right, well done. If you didn't, let me explain. The diagram shows the cross-section of a progressive transverse wave travelling at 24 centimeters per second on water. The amplitude of the wave is 2 centimeters and the frequency is 4 Hertz. Which statement is correct? So the phase difference between particles at P and S is pi over 2. Okay, so let's just put the phases on here. Let's just call position P phase 0 radians, at position R that would be pi radians, and at this point here that would be 2 pi radians, which means at Q you would have pi over 2 radians, and at point S 3 over 2 pi radians. So we could say the phase difference between P and S, we could say it is 3 over 2 pi radians. That would be a true statement. However, point P is also at the same point in its phase as this point that I've just drawn here. And we can see the difference, the phase difference between here and here is pi over 2. So that is also a true statement, which is why A is correct. Let's look at the other questions and see why they're not correct. The distance between P and R is 6 centimeters. Well, if we want to find the distance between P and R, we'd have to find the wavelength, because P and R is half a wavelength. So let's use the equation. The speed of a wave is equal to its frequency multiplied by its wavelength. That's straight off your data sheet. So we've got a wavelength is equal to the speed over the frequency. The speed, we're told, is 24 meters per second. I would normally convert these to standard units, meters per second, but I'm going to leave it as 24 centimeters a second, just to try and speed things up a bit quicker, as it's a multi-choice question. Frequency was 4 Hertz, so we've got a wavelength of 6 centimeters, but the wavelength is that distance between P and R. That's half a wavelength, so that would be 3 centimeters. So that is an incorrect statement. The velocity at Q is at a maximum. No, it's actually, that point is stationary at that, just for that instant. It's not moving at all. So that's incorrect. And particles P and R are in phase. Well, P and R are nodes of the wave. Sorry, they're not nodes of the wave at all. It's a progressive wave. P and R are 180 degrees out of phase. We could imagine in the next moment, although they're in the same position, we can imagine in the next moment P will start moving downwards and R will start moving upwards. So they're 180 degrees out of phase. So the answer was A. I hope you found this video useful. If you did, click on that subscribe button please. Give me a like, share with friends, and certainly watch more of them. Thank you very much.